All right. Good afternoon, everyone. Did you all have a good lunch? Ready for some data management, the good, the bad, and the ugly? All right. My name is Jason Pohl. I'm a Principal Solutions Architect at Databricks. I'm also the leader of the Data Management Subject Matter Expert Group. And I'm joined today by one of our customers, Mary, who's a senior engineer over at Northwestern Mutual. She's going to be talking a little bit later in the program. So let's just get into it. I want to talk about data management in general and what's good about it, what's bad about it, what's hard, and how Databricks and the Lakehouse platform makes it simple. So we all know that data is critical for business outcomes. Everybody wants to be data-driven, but being data-driven is hard. You have to be able to harness all your analytics. This includes historical as well as predictive analytics. And you have to leverage the data in compliance with regulation and other data governance. So to be able to do that, you have to basically get access to the data. So there's complexity in all this data delivery. If you think about it in its simplest form, you've basically got all these raw data sources on the left that are raw and unfiltered, and you've got all your interesting use cases on the right, things you actually want to do with the data to achieve your business outcomes. But getting there is a little bit hard, so I'm going to explain a little bit why it's so challenging. So first of all, you've got to get the data ingested into your data lake, which would be on S3 and AWS. And so this could be structured data, could be unstructured. If you're pulling from databases, that might involve change data capture. And this could be batch or streaming. Once you get it into your S3 data lake, you're going to need to enrich it a little bit. So you need to transform it, cleanse it, and there's any number of tools to do this. So you can use Python, you can use SQL, you might be using Glue, you can use Apache Spark, perhaps. And this could be in batch, or it could even be in streaming. Now, historically, what people have done is they have this hybrid architecture where you ingest all of your data into your data lake on S3, and then there's a subset of data that you would then replicate into a data warehouse that you would then use to serve up for business intelligence purposes. And you do this because data warehouses have been really good. They've been around for decades, and they allow you to have really fast query performance and scale that out to a number of users and have ACID-level transactions on them. Data lakes were really good because you could write any amount of data into it. So it didn't matter if it was structured or unstructured, if it was terabytes or petabytes, data lakes could hold it. And if you're doing data science, you tend to like to build models on your data in its rawest, most granular form. But data lakes were not really great at performing high-performance BI-style queries. So you might have heard something called the Lakehouse, which is something that Databricks has been moving towards, and it's an architecture that we firmly believe in. And what it is the recognition that now you can have data warehouse query performance on top of a data lake. And you don't have to replicate a subset of that data into a data warehouse anymore, and you don't have to try to keep those two things in sync. You can basically write your data in one place on S3 and then have all of your use cases and all of your analytics done on top of it. So back to the old world, though, when we have this hybrid model of data lakes and data warehouses, after you've ingested your data into your data lake and you've enriched it in some way and done some transformations, you need to basically start to monitor and tune that. So every one of those engines or tools that you use to enrich your data, you're basically going to have to ship data and integrate it between one and the other, and you're going to have to monitor those things. You have to monitor for uptime. You have to monitor if things fail. Sorry. You have to monitor if things fail, need to be rerun, or if your service degrades over time, you need to be able to recognize that and then take proactive action. So each hop of the data, you have to monitor that. So the more tools you have, the more monitoring and the more maintenance you have. Now, whenever you go to do this enrichment and transformation, you probably are dealing with a lot of different steps, and those steps need to be orchestrated in some way. So you need some sort of workflow engine that's going to allow you to basically schedule things to kick off, figure out what the dependencies are, run an orchestration workflow with those dependencies, and then monitor everything to see if it's running and if it's on time. And then if something fails, you need to be able to restart it, and that could be either automatic or manual. And then finally, as you're doing this and you're ingesting all this data and you're using all these different tools, you need to make sure that you're governing it in the right way. And each of these different tools and engines, they have their own different governance model, especially when it comes to fine-grained security or if you're doing role-based access control. And you have to make sure that all these things fit together. And if you're operating in a highly regulated industry, you have to make sure that you're adhering to the various compliance policies and procedures as well. And if you ever wanted to share your data outside your organization, that brings another level of challenges of making sure you're doing that in a secure and safe way. So ultimately, all these different tools that you have to use distract us from our real goal, which is take all the data that you have available to you and use it to make the best possible business decisions for the business outcomes that you need, and to be data-driven, essentially. So I'm going to go now and tell you a little bit about how Databricks makes that data management lifecycle a little bit easier. So this is a bit of a journey I'm going to take you on. So this journey is going to talk about all those different steps I talked through about what makes data management hard and how we're making it simple with the Lakehouse. So first, let's start with the ingestion. Whenever you go to ingest data into your data lake, we have something called Autoloader. What Autoloader does is it's a data source for Apache Spark, but when you use it, it'll automatically set up certain infrastructure in AWS. So it'll set up a notification, S3 notifications. It'll set up an SQS queue to put those notifications to. And then any file that lands on an S3 bucket, it'll use that notification service to automatically ingest it and then scale it into your pipeline. And by doing it that way, you can basically scale up to millions of files. It doesn't really matter how many you have. The other thing it does is that it infers the schema. So let's say you're ingesting some JSON data, and you're ingesting that in, and it detects that a certain field is an integer. It'll automatically cast that field as an integer. But as your pipeline is running, if you get some data that it doesn't look like an integer anymore, maybe it looks like a double or a float or something, then what will happen is Autoloader will automatically detect that. It'll capture the data, put it into an extra field, we call it a rescue data column, and then continue and let your pipeline continue. So it doesn't fail your pipeline and allows you to go back after the fact and figure out, why did this data change? And maybe it was a valid change and the upstream developers just didn't tell anybody about it, or maybe it was just some bad data. Typically, whenever that happens, it's because two different developers were developing against developing two different things, and they were not really coordinating on the same schema, at least with JSON anyway. And so you can essentially evolve this schema over time automatically with Autoloader and not have to worry about any sort of scalability problems. All right. I think I already talked through my next slide. So now, not all of your data is going to land on S3 that you need to ingest into your data lake. You're going to want to ingest data from other sources too. Let's say you've got data in Salesforce or Marketo, and you want to get that into your data lake to do some analysis, maybe some conversion analysis or something like that. Well, you can do that with Fivetran or Airbyte or a number of partners. We've got something called Partner Connect within the product where if you go to that screen, you can choose from a basket of registered partners, and then it'll click through and allow you to easily connect your account that you've already got set up with that partner into Databricks. Or if you haven't used that partner yet, it'll go into a registration flow so you can easily start a trial and try it out. In addition to the ingestion partners like Fivetran and Airbyte, we've also got some data transformation. So dbt Labs, if you're using dbt, you can leverage that and run those same dbt models on Databricks. And finally, if you wanted to connect your favorite BI tool like Power BI or Tableau, we've got a number of connectors for those as well. All right, so you've got all the data into your data lake. It's in S3. Now you need to do some transformation and cleansing. So the best way to do that in Databricks is Delta Live tables. And I'm going to show this in a demo. But DLT is an opinionated way to do data transformation, data pipelines, essentially. And what it is you declaratively build out your data pipeline, and you can use either SQL or Python to do that. And you're going to include, you're basically just building out think of it as create table as statements, CTAS statements, but you include a special word called live. And what it does is it's going to then figure out, as you build it out, what are all the dependencies that are needed to make this data flow work. And you can include comments in these things and be able to basically add some data quality rules as well. So I think here, when we're talking about data quality, we've got these things called expectations. So when you create an expectation, it's essentially a business rule. And if you violate that business rule at runtime when you're loading data through, it'll basically capture that, flag it, count it, and then you're in control of what you want to do. Do you want to fail the pipeline? Do you want to just count it and alert somebody, or do you want to quarantine it? You can set that stuff up within your Delta Live tables. The other cool thing that DLT does is it's really well integrated with the resource management of the scheduler. So as you're running it, it'll be able to detect how much data it's yet to process and auto-scale the size of the cluster accordingly. So if you operate in an industry where you have some seasonality in your data, let's say in retail in like November, December, you get way more data than you usually do, this can be used to automatically size the cluster to make sure you're meeting your SLAs. And finally, there's I mentioned how it automatically figured out the dependencies. Whenever you go to run it, and I'll show this in the demo, it'll build out that DAG for you, and then you can go and look at each individual step in that DAG and figure out where you're at in the pipeline and if anything's failed or not. So not everything that you transform in your data lake is going to be done with Delta Live tables, though. You're probably going to have a reason to use general orchestration as well. So as an example, let's say you're building an application where you want to scrape some web data with Python, load that to a Delta table, and then do some analysis on it, and then use that to build a machine learning model. You're going to have various incremental steps that you're going to need to orchestrate and make sure they run in a specific order. You can do that with multitask jobs on Databricks. So multitask jobs allows you to easily orchestrate these things either with our UI or through our API. It's fully integrated with the Databricks platform, and it works across all the clouds that we support. We've had Databricks jobs now since the beginning, so today we're running millions of jobs every day on AWS with the job scheduler, and we've built up the infrastructure to be able to do that and reliably at scale. The other cool thing that our job scheduler does is it can run either batch or streaming, but with batch jobs, you really just want to spin up the infrastructure, the EC2 instances you need, run the job, and then when it's finished, you shut them all down. That's what our job scheduler does. So you're only paying for those EC2 for the amount of time that you're running something on there. And after it shuts down, what it does is it snapshots all the metrics, all the logs, notebooks if it's a notebook job. And so that way you can go in after the fact and see what happened. And if it failed, you can troubleshoot that job without having to pay to keep these EC2 instances up and running the whole time. Now, some of you might be using Airflow for your orchestration already. And we found that a lot of our customers use Airflow. You can integrate Airflow with Databricks, where we've got a special operator so you can run Databricks jobs on that operator. But we've got something new up our sleeves, which I'm happy to announce that we're in preview now. If you have an Airflow DAG, you can basically take that DAG, run it on Databricks with our CLI, and then it'll basically leverage the same infrastructure as Databricks jobs. And then when you go to look at that Airflow job with that DAG and how it's run, we've captured all the metadata, and it shows up in the same UI and the same interface as you would expect out of a Databricks job. And the best part is we have this reliable scheduling built in. So if you were to run 10 simultaneous Airflow DAGs, what we do under the covers is we create 10 different instances of Airflow running. So it insulates you from what we call the noisy neighbor problem, where you might have one Airflow job that's taking up all the resources, and it crowds out the ability for these other 9 jobs to run. On Databricks, you don't have that problem. So just to summarize, with our multitask job service, you can have DAGs of any task across any platform. Now, you've ingested the data in your data lake, you've enriched it, you've been monitoring it, and you've orchestrated it. Now you got to make sure that it's governed appropriately. We announced this new product called Unity Catalog earlier this year. It's in private preview on AWS right now. And what it is it's fine-grained data governance across all of your data and AI assets. So today we're focusing on tables. Next year we're also going to include machine learning models as well. And the idea is that you'll be able to use regular ANSI SQL to create grant statements that then are used to grant access to individual users and groups to your tables. And this includes column-level access, row-level access, and eventually attribute-based access. So in this example, I can create an attribute called PII and then assign that to certain columns on a table, and then grant access in this example so that this group named product managers can access anything in the database IoT data, except for anything that has the attribute of PII. This is a UI mock-up of what Unicatalog will look like. But it's going to encompass a number of things. I talked about the data access control, but every access to tables is going to be audited, so you'll be able to have an audit trail of all access. It's also going to have built-in data lineage, so any ETL job you run on Databricks, whether that's a Delta Live table or a regular Apache Spark job, will capture that lineage automatically, and then we'll index it and make it available for search either through the UI or through an API. And then finally, because you're able to tag and add descriptions for all the different columns and tables, you'll be able to have better data discovery across all of your data and AI assets. And registering a table once in Unicatalog allows you to use it across any of your workspaces on Databricks. Now, some of you might have data sharing use cases where you've curated these data sets internally, but you want to be able to expose them or share them externally to either partners, suppliers, customers, et cetera. So earlier this year, we introduced Delta Sharing, which is the world's first open protocol for data sharing, and allows you to do it in an open source way and a secure way. And this allows you to share data in place in your data lake with however many people or many recipients that you want to grant access to. And it's got a wide ecosystem already. If you're sharing a small amount of data, if somebody has a Delta sharing client, they can basically use Pandas or even Power BI to look at that data. If it's a lot of data you're sharing, like petabytes, then your client can use Apache Spark to ingest that data as well. Because it's all based on S3 and it's all highly available as a global service on AWS, you can easily get to this data anywhere in the world. So just to summarize, Delta Live Tables makes the experience of building reliable data pipelines on Delta Lake extremely easy. With Unicatalog, you'll be able to secure all of your data and AI assets. That's hard to say. And Delta Sharing is the world's first open source Delta Sharing protocol. All right. So next, I'd like to welcome Mary up to the stage from Northwestern Mutual. I personally have a Northwestern Mutual life insurance policy, so I'm very excited. I'm happy to trust my life with Northwestern Mutual. I'm glad that they trust their data governance with Databricks.
Okay, you need to give me the...
Oh, yes. Sorry about that.
Thank you.
I'll stay over here, too.
All right. So as Jason said, I'm Mary Golombieski, and I'd let him off trying to pronounce that. I work for Northwestern Mutual. So I'll give you a little background. Northwestern Mutual is a financial services company. We're the largest direct provider of life insurance in the United States, and also among the top 10 broker-dealers in the United States. So it's a very large, established company. I've been with Northwestern Mutual for a few years now. I started out as a data analyst with the investments division when Insights, which is the team I'm on now, started out 5 years ago. I was a SME for the project. I joined the team 2 years ago, and now I run 2 of the engineering teams. So what does the Insights team do? We provide consolidated reporting to our field and home office. So we have about 20,000 financial representatives, their staff, their leadership out across the country, and about 7,000 in our home office in Milwaukee and New York. We've expanded now. We have an office in New York as well. The data that our team does is to bring together practice management data. So revenue, sales activities, and contact management. So we have on one side the very old established life insurance company, and on the other side, the very young investments division. So what our job is to take the data from those legacy systems and the new systems and make them all work together. That can be very challenging. So this is, I brought some examples of some of the stuff that we do. So this is our revenue spotlight, which was actually the first report that was migrated. And so this is a report that a financial representative can look at, and they can, it has some interactivity to it, so they can look at different product lines, they can look at proportions of where their revenue is coming from, they can look at growth rates, they can explore different time periods. All of this didn't exactly exist before without going to, a report over here and a report over there and a report someplace else in the middle. So this was bringing this all together into one place. Then we can drill down a little deeper. This is another revenue, but this focuses on advisory fees. So now this gives them breakdown within the programs that they sell. And what is the money coming in, and how are all the things that come out of that, and where are they making the most, and what things should they concentrate on? And again, what time periods do you want to look at, and how has this grown? So all of these things now they have access to. So this report and the one before are Power BI, and then we even get down to, if you wanted to know on that other report where this number came from, this is an SSRS report that will tell you where that number came from. And that makes the data more transparent and more reliable for the field, because it can see where those numbers came from. So that's what we provide to the field. Insights has grown a lot in 5 years. We went from 5 employees and 2 reports in 2016 to 45 employees and 60 reports today. Along with that, the data has grown tremendously. Along with all of that comes growing pains. What we were getting to was that the structure that we had for our data was starting to have performance issues. And as much as we would try and tweak that, we were going to run out. We were going to run into the point where the performance would not be what we wanted for the field. Our goal is for our reports to render in under 10 seconds, and we would prefer them to be almost instantaneous. So we had to do something to get past that. Let's see. A single node with no parallel computing capacity couldn't keep up. And we wanted to be able to scale out and not just up. And so that's where we came to the decision that we were going to go with AWS. So this is a look at our architecture. Before migration, we were using SSIS for ingestion of the data. And then the data was stored in SQL Server databases and analysis services cubes. The visualization layer is, as I said, Power BI and SSRS. After the migration, we're using Databricks with Airflow and a custom framework, and I'll talk a little bit more about that as we go on. And instead of analysis services, we're using data sets within Power BI. So during the migration, we were running both of these in parallel for some time. During the migration, the users of the data had no clue whether they were on the old system or the new system. The idea was that there would be minimal disruption. So why did we pick Databricks to go with AWS? Well, there were 3 main reasons. Security at Northwestern Mutual is a huge concern, always. We have our clients' financial data. So that means we need to protect it. So we needed to have it be in a private cloud, and encryption was a huge deal as well. It had to be encrypted in transit, and personally identifiable information, or PII, encrypted at rest. We wanted to have one set of data for all of the users. So my team, data analysts in other areas of the company, and data scientists. Some of those people need to see the PII information, some don't need to see it. But we want to have one set of data. Okay? And then the last thing was, we wanted to keep our engineering teams. We didn't want to have to hire all new staff. We wanted them to come along with the project. And so by the custom framework, we are able to set it up in such a way that they're mainly using SQL, which they already knew. So the other pieces that they have to do, they were able to catch on very quickly. So when I asked my engineers what do they like about AWS with Databricks, this was some of the feedback I got. Of course, going to the cloud, we're not as concerned about size. So they can bring in an entire table instead of having to go back later because another project needs another field from this table. We just bring in the whole table now. Multi-threaded processing means processing times are faster. Airflow handles dependencies better, and this kind of goes with the DAGs, and Airflow is the scheduler. But this is an example of one of the dependencies, and this is a very simple one. We have ones that are much more complex. But the visual nature of this allows it to be very simple for the developer to see that they've caught everything that they need to do. And they can see what comes before and what comes after this job that they're working on. So that made it very clear and very easy for them. The developers themselves said that the transition was easy. As we were working on this, they were working on the old system and the new system, so they had the comfort stuff that they were working on, and then they had the little bit new stuff. So they had a little balance, and they had a little time to adjust. So that was very good. One of the new features that they really like is time travel. So if there's an issue with the data, they can look back and see, is it a change in what the data is, or is there something else going on? And if we have to restore, it's a very simple and fast process. And then finally, notebooks have made analysis much easier. We don't use notebooks for scheduling at all. We do use them for development. We use them for ad hoc queries. We use them to collaborate with each other. And it really makes it an easy way to bring certain subject matter together into one notebook so that if you have to go back and review it later, it's all there in one book. You don't have to go and look for where all the queries that are related to this issue. So our migration, I would say, was very successful. We're continuing to learn. We're continuing to add new things. And that will continue into the future. AWS is continuing in Northwestern Mutual. Right now, we're working on the investment data being migrated from DB2 to AWS. So thank you.
Thank you, Mary. All right. So now I'd like to show you guys a little bit of demo. Does anybody want to see a demo? Yeah. Hey, here we go. The after lunch crowd. There you go. All right. So first thing I want to show you is Databricks SQL, which I talked about a little bit. So if you were to log into Databricks SQL, and then I should mention that within the Databricks application, you've got three separate applications all in one. You've got Databricks SQL, which I'm about to show you, machine learning, and data science and engineering. Machine learning is for if you're building and training models and you want to basically manage that life cycle. And then data science and engineering is more like if you're exploring your data or if you're doing any sort of data engineering. And I'll show that one for Delta Live Tables. But first off, with Databricks SQL, I'm going to go ahead and open up a dashboard. So I've created this dashboard that looks at New York City taxi trips in 2016. And you can kind of see, within this single dashboard, I can basically create lots of different panels with different types of visualizations. And if I wanted to do some interactiveness, I can create some widgets and put them on there. So let's go ahead and just add a couple more zip codes here. If I go to apply changes, it's going to rerun that query with the new 3 zip codes, and then get the data and present it. So, and then each of these, behind each of these panels, each of these visualizations, I basically got a query. So if I were to go to View Query here, in here you can see what the SQL is, and this is an interactive SQL query editor. So it's got type ahead functionality. As you're typing, it'll try to figure out what you want. And I've also got a data explorer over here to the left, or a schema browser, and I can basically go through and try to see what tables I want to explore. So if I wanted to get a bit more real estate, I could get that out of the way. And then as I run this, all the results come down here. And then I can also create the different visualizations. So then this one I've got over here, but if I wanted to, let me go back to here, and if just to kind of show this one, I can take this chart and just click on this and duplicate it. And then I can, here I've duplicated it, and if I wanted to, just, let me get edit visualization. Now I can, basically turn this into any number of different visualizations you would expect in a dashboarding tool. So I'll keep it as a bar chart and then basically just kind of make it a horizontal instead. All right. So now I can have multiple visualizations against the same query. And for this query, if I wanted to, I could actually share this. So there's other people in my organization, like I've shared this with my colleague Amit. He can actually, I can choose if I want him to be able to run this or just edit it. And then, unless I've shared it with someone, they're not going to be able to see it. Now, you can see that this query is attached to a particular endpoint, a Databricks SQL endpoint. If you kind of look at what that looks like, I've got a number of different endpoints here, and I've been running against this one, which is up and running in classic mode. But we've got a new thing called serverless. So this is the age of serverless. So if I go ahead and click that, what Databricks SQL Serverless is going to do is we've basically got like a whole fleet of servers running in the Databricks account. And then as I go to spin up a serverless endpoint, it's going to basically requisition a number of those different nodes within this fleet and then set them up as a Databricks SQL cluster just for this particular environment to use, and then make it available for any sort of queries to be handled. And it looks like it's up and running. So it takes about 10 seconds or so to get it up and running, and then you can start running queries. And that's, if that's from me like starting it, or if I had a BI tool like Power BI that was connected to it already, that first query would automatically fire it up. So just kind of looking at this, you can kind of see we allow you to create a SQL endpoint based on t-shirt sizing, we call it, so extra small, medium, large, et cetera. And then you can specify the number of clusters that you want. So I've got 1 minimum, 2 maximum, but you could have any number of clusters that you want to automatically scale. And what the endpoint does is essentially a load balancer. So as the queries come in, it just dishes them out to the different clusters that are available. And the clusters themselves can auto-scale as well. And if I were to go to these connection details, you can see that there's a JDBC URL. So if I wanted to not use the dashboarding tools that I was just showing you, but rather my favorite BI tool like Power BI or Tableau, or anything else that basically accepts the JDBC connection, then I can connect it to this JDBC URL and leverage the endpoint that way. It's also worth noting that this one is running Photon. So Photon is our next generation engine. What we did is we completely rewrote the guts of Apache Spark, and we did so in native C, and we used vectorization techniques so we can take advantage of advanced SIMD chipsets within the modern CPUs. And all of this basically allows the queries on Databricks SQL to go faster than any other Apache Spark distribution out there. And the result is that we actually just broke the world record for data warehousing performance. We performed and submitted and then got audited the TPC DS benchmark, which showed that we beat the prior record holder, which was Alibaba. And we did it, not just faster, but also on better price performance as well, specifically on AWS. All right. Another cool feature is if I wanted to create an alert, excuse me, I can go here and select this previous query I have, which is total trips. And this, I can see that this query, it's the last time it ran, it basically had a result of 289. I think it might be cool to know if the total trips ever exceeds 300. So what I can do is I can create an alert that says if this value ever goes over 300, go ahead and create this alert and then email myself. And so you can have these alerts either send emails, set up a Slack channel, anything with a webhook, PagerDuty, et cetera, and then figure out like what is the schedule basis. So how often do I want this query to run and check? All right. I talked about the Schema Explorer earlier, but in the Data Explorer, for any table, I can go to a table here, and I can see if I click on permissions, this goes back to the data governance, I can choose like who I want to allow to query this table. So if I wanted to, I could go back to my colleague Amit and give him the ability to select this table and read the metadata, but not really make new tables or modify them at all. And so you have these fine-grained granular permissions throughout the Databricks platform. Now, I talked about Partner Connect just to kind of show you what that looks like. If I wanted to ingest some data into my data lake straight from, like, say, Salesforce, I could use Fivetran to do that. Likewise, if I wanted to do some transformations using dbt, I can integrate with dbt Labs using it here. Now, I want to show you how to transform some data using Delta Live tables. So if I click into Data Science and Engineering, it's going to take me into this application, which allows me to use interactive exploratory notebooks. All right. So if I click on this recent one, I've got, let me zoom this in. So here I've got a notebook. It's got 2 different commands that I put in there. It's a SQL notebook, and I'm basically writing a Delta Live table. So what I've done is, it's basically, you can see a create table as statement, but I've included a few new things. I've included live, which signifies that this is a Delta Live table, and and it'll basically have to understand what all the dependencies are. It's also got this incremental word, and what that does is every time this runs, it'll incrementally look for what has changed in the data source since the last time it ran, and then get just those changes and push them through the pipeline. I can add comments so that when people go to search for this, they'll find out that this is some raw sensor data, and I got it from JSON. And here I'm basically selecting from this thing called Cloud Files. So Cloud Files, it's a table-based function, and what it does is it's just basically a proxy to Autoloader. So I talked about how Autoloader, we automatically set up S3 notifications and SQSQ to be able to figure out what files have changed or been added. And this is basically going to look at an S3 bucket called data sensors and look for JSON files and ingest them appropriately. Now that I've got this table called raw data, I'll create another live table called readings. And so readings is reading from live raw data. And it's not doing a lot, this is a demo, but it's basically casting this timestamp to timestamp, and it's casting the reading to a double. And then I've also included a constraint. So this is like these expectations I was talking about, where for the valid timestamp column, I'm expecting this timestamp to not be null. And if it is null, I don't want the pipeline to fail, but I do want to know about it. And just like I could share a dashboard with other people in my organization, I can also share this with my colleagues here. So I think I need to. Yeah. Oh, this is actually not my notebook. It's been shared to me from Amit, so I can't actually share it with anybody else. So there you go. The other thing that we have is built-in revision history in our notebook. So every change that I make to this notebook, it automatically gets snapshotted in a version. And I could go back in time to a previous snapshot and then restore that revision if I want to. So this helps you to be able to collaborate securely. So it's great to be able to share notebooks and have multiple people work on it, but if somebody makes a change that breaks what you're working on, you want to be able to roll back to that as well. Now, if I were to look at what this DLT pipeline looks like when running it, we've got, let me zoom in here. So all I did was create 2 different SQL statements, but DLT know to basically create a dependency across those and create this DAG. And whenever I go to run this, I can choose to run this in production mode or development mode. And it does a few things, but it's really convenient. So in developer mode, I'm basically going to have a cluster that's up and running, and I can keep running this over and over again and iterate on it. And then in production mode, it's going to basically be more ephemeral. So if this is set up to be a batch pipeline, then in production mode, it would spin up the cluster, run it to completion, shut down. If this was a streaming pipeline, it would continuously run that cluster. But if it's just meant to be batch, then production will shut it down. Likewise, if something fails, in production mode, I can set it so it automatically retries it n number of times. Whereas in development mode, you probably don't want to keep retrying because you're in development and it's probably failing for a reason. So I can go ahead and start this and let it go. And as it's running, I can see all the different metadata here. I can see this path that will take me back to the notebook I was just on. And you can see, as it's running, what are the data quality. So I'm sure every data pipeline looks like this, but 100% of everything is good. But if there was anything that didn't match my expectations, it would have failed there. And I've got a history or a log here of all the different operations that were being performed as I was running this Delta Live table. And if I wanted to, I could do a full refresh as well. So because I set this up as an incremental pipeline, every run of it is just incrementally getting more data, but a refresh would completely refresh it. All right, and then all the operations in this log table that are being captured, they're also accessible via a Delta table and an API as well. All right. Well, let's switch back to the slides, and I think we're going to have some time left over for questions if you guys want. All right, so just kind of going back to this journey we were on with data management. We ingested the data. We used Autoloader to do that. We enriched the data using Delta Live tables and building these declarative pipelines for data transformation. Then we were monitoring and tuning that with DLT as well. We scheduled these pipelines using a Databricks multitask job scheduler. And then we were able to govern the data by assigning different permissions along the data to different people in an organization. We're using Unity Catalog to do that. We didn't actually share out any data, but sometimes you need to do that. And now we're actually at the end of the journey, which is like doing the thing we wanted to do in the first place, which is all those use cases on the right side of the original screen. So we talked about Databricks SQL. I mentioned we recently broke the record for data warehouse performance. So this kind of dispels the myth that you can't have good performance on top of a data lake. You can have the best performance on top of a data lake, which allows you to basically write your data into one place and then use it for all your different use cases, whether it's historical reporting with SQL or building predictive analytics models with machine learning. And this allows you to have a native SQL interface. And I was showing you the Databricks SQL dashboards, but you can connect any BI tool that can basically connect with JDBC as well. In addition to historical reporting, if you wanted to do more predictive analytics with machine learning, we've got a whole platform built up where we've created an open source project called MLflow. We open sourced it, I think, 3 years ago now. And what MLflow does, it does the entire machine learning lifecycle. So everything from discovering data, training a model, running a bunch of experiments, picking the best model, putting it into production, monitoring it, and doing it all over again. We built MLflow to do that, and we made it open source because we wanted to build a whole community around it, because a lot of data scientists, they're never just using one set of libraries, not just using scikit-learn or just using TensorFlow, but they're using a combination of these, MXNet, TensorFlow, PyTorch, SparkML. And so MLflow allows all of these different libraries and platforms to integrate into a common machine learning lifecycle. I'd also like to point out we announced something called AutoML earlier this year. What AutoML does is you essentially just look at a data set, you pick a column, and you say, I want to predict this column. And then what it'll do is it'll build out an entire notebook for you with all the code you need. It'll do several runs. It'll log everything in MLflow, and then it'll present it to you with like a reasonable model. But the point is that it's doing all this this legwork for you so that a data scientist can then go in this notebook and then find the best possible fit. So it gives them a better starting point without having to do that all themselves. And if you're new to data science and you're just learning machine learning, it's a great way to actually learn how to build these things. And everything is tracked, so if you make a mistake, you can always go back to a different revision. And ultimately, one of the challenges with machine learning in general is reproducibility. You want to make sure that if you build a model today, you should be able to reproduce it in 2 months or 2 years' time from now. And to do that, we use MLflow, so we track everything. We track all the inputs that were used. We track all the versions of the libraries that were used. And then we also have Delta Lake, which you can run, you can use time travel to run queries at a point in time in the past. So if I trained my model 2 months ago, I should be able to run a query as my data lake looked 2 months ago and use that data to retrain it and produce and reproduce the same result. Likewise, we just introduced a feature store which allows you to create and version these features. So if you've got 10 different models that are essentially all dependent on the same feature, you can build it once and then version it and model it and keep it consistent to help aid with reproducibility. And with data science, Databricks almost got famous for our data science notebooks because it was a simple way to bring up a notebook, attach it to a cluster, run some interactive exploration, and then share that in a secure way with people in your organization. So just to summarize, the Databricks Lakehouse platform, we allow you to have world-class performance, so data warehouse performance with data lake economics. It's built on top of all the things you love on AWS, so S3 and EC2. It's the foundation for all your data, BI, and AI workloads. And it's one source of truth. And because we use open source software and we are heavy believers in open source, even if we didn't create the open source, we're adopting Airflow so you can run those easily on Databricks. We're adopting dbt so you can run that easily on Databricks. You don't have to worry about lock-in because you can basically, as long as you're using open source, you can run those anywhere you want. You can run the same job on EMR with Apache Spark as you can on Databricks. It'll just run faster on Databricks. So that's it for now. If you're still around today, please come visit us. We're at booth number 992. You'll see a big lake house. As soon as you walk through the doors, we're all the way in the back. And we've got a pretty cool virtual reality bike if you want to try it out as well. So I think we've got some time. Is there any questions for anyone? For either myself or Mary? Yep.
Mm-hmm. There is an intermediate step or an intermediate table which is does a lot of complex joins, and so because of that it's bottleneck, the DAG is bottleneck. And so I have a couple of questions around that. So first, is it a best practice to just track sort of where my data is, how many records from the beginning each table has? What is the best step best practice to know exactly where each of my intermediate tables are at? Because it seems like from the design, those offsets are kind of abstract to us. We don't really know how the data is moving between from one table to another.
Yep.
And secondly, what kind of auto scaling or manual scaling would I do at that point? What kind of options do I have to scale that bottleneck down?
So in our case, if you have a query that's very complex and has multiple tables in the DAG, you're going to have each of those tables is going to be a dependency. So it won't run that query until all of the dependencies have been done.
And so how does that apply to live table? Because live would be a set of data coming in and then again that same set of data coming in. So
yeah, so Delta Live Tables, it builds upon a few things. So it builds upon structured streaming. Structured streaming, basically, if you have a structured streaming data source, you have to have some way of knowing a watermark of where you're at, right? And then being able to replay from that point forward. And once you start writing to a Delta table, Delta tables maintain their own transaction log, so they already know a list of history. We also, on Databricks, have something called change data flow. So you can, within a Delta table, you can run a query and it'll show you every single insert, update, and delete on a table. So basically, as long as you're using something that's supported with structured streaming to get the data in, and then from that point forward, everything is Delta, you have the ability to do this under the covers, and you don't have to think about it, you just use that incremental keyword. Oh, we got one over here. I'm sorry, I can't hear.
No, you were dealing with the access control thing. So access can be granted at the object level only, or you support row level and column level entitlements as well?
So the question is, for access control, what level of granularity can you basically grant these access controls? So in Databricks, we've had the ability to do table level and row level with dynamic views. With Unity Catalog, we're going to have the ability to do column level as well as attribute-based access control. But fundamentally, with Unity Catalog and the data governance of a lakehouse, you want to do the governance at the table level and not at the file level, because it's really bad to do governance at a file level for various reasons. But you want to have good performance, and you want to be able to make sure that you're not complicating things, because you might want to reorganize your data physically at the file level in a different way than you logically represent at the table level for performance reasons. So. Well, with Unity Catalog, you'll be able to basically create like a policy that says, I grant you access to these 2 columns and these 2 columns only. And then when you go to query that, we enforce that as part of the execution on the cluster. Okay. Yeah, the question is, can you grant that access programmatically? So all the access that you'll be able to grant is you can do it through ANSI SQL grant statements, or there'll be a REST API on Unity Catalog where you can basically fire off the same grants. Yes?
And notebook be part of the Unity Catalog too. So like when people are running a catalog, they're going to be, notebook, they're going to be pulling data into it when they say, we need to have access controls on it.
Yep, so the question is, if you're basically querying a table with a notebook, you're gonna have to have access controls on that as well. So we've got built-in role-based access security for notebooks so that you can choose who you're sharing that notebook with and if they have the ability to read it, to run it, or to modify it.
But is that linked with Unity?
Yeah, so essentially once you create the permissions on a table in Unity Catalog, then those are enforced for all users across Databricks, regardless if they're using Databricks SQL or a notebook or Power BI or anything. It doesn't matter, and it's across workspaces as well. Oh, one more?
A pretty high-level question. So for companies that have a pretty large Redshift deployment, do you see Databricks as a next-gen replacement or a complement? Of what's the use case for each?
So the question is like, if you've got a big Redshift deployment, as Databricks replacement, we've I think complemented Redshift over the years in terms of a lot of people were running, well, it's not really a Redshift thing, but any data warehouse. You're basically running a bunch of BI queries and a bunch of ETL queries. And you usually have some sort of fixed constraint capacity. And you can't run all of your BI and all of your ETL at the same time, otherwise it falls over. And so what people do is generally schedule the ETL overnight so they can run their BI queries during the day. So what we've done historically is help people offload that ETL out of Redshift so that they can basically use it on Spark and do it with ephemeral clusters so that you spin it up, run your ETL, and then shut it down. We've had a lot of success with that over the years. But now with Databricks SQL and Photon, we're able to run these same BI queries on Redshift that we might not have been able to do before. So I think we are a pretty good replacement. So, yep. The question is, will we support running jobs external to Databricks on the new Airflow? And the answer is yes. So, I mean, one of the reasons why we want to adopt Airflow, it's, like it or not, it's kind of like the de facto standard now for orchestration. Like everybody uses it. There's not as many people that use it that love it, but they use it. And it's built up this pretty incredible ecosystem of plugins and operators that people are using for any number of things. And we want to be able to continue to support that community. Do you have any Airflow anecdotes or anything?
Well, like I said in the presentation, it really lets us see those dependencies and monitor the process and lets us start a flow in the middle. So it's worked really well for us. Much easier than the SSIS scheduling we used to do.
Do you host and maintain your own Airflow server, or do you use hosted Airflow on AWS?
I think we have our own server, but that would be not in my area. So.
All right. Yes? Yep. So we're currently building out the attribute-based access control within Unity Catalog, but in the example I gave, we basically tagged a few columns with PII. So signifying that, you know, this should have some sort of policy. And so I think if you were able to do that, we're building the building blocks right now, but you can kind of conceive in the future where there could be something as you're ingesting data where you analyze, maybe it's running some regexes, that this looks like a social security number, let's say, and you can tag that as PII, and you've already got a policy that only certain people can see the PII. Then you can do things, and you could say, like, if you're in this group, you see it in the clear. If you're in any other group, you just see a masked or a redacted version. And then you could have those policies throughout all the tables, and then, you know, that PII metadata could be carried through the pipeline to every table where that column goes.
That's what we do with our PII information. My team can see it because they're building the reports, but like if we gave it to the data scientists or the analysts outside of our group, they don't have any need to see who this client is. They're doing an analysis over a group of things, so they don't ever get to see that.
Yep.
One more quick. So Unity Catalog, great aspiration, obviously an important component. What's the timeline?
It's in private preview right now on AWS. It's not fully in private preview on the other clouds we support, but for AWS, we're leading with that one. So if you're interested, reach out, if you're a Databricks customer, reach out to your account manager, and we'll try to get you in the preview. All right, I don't see any more hands. All right, well, thank you everybody for coming, and hopefully this will, you know, you've learned a little bit more about data management and the good and the bad and the ugly about it. And thank you so much to Mary G for helping talk about Databricks.
Thank you.